lecture, I'll give you a very brief introduction of what a flyback converter and flyback transformer means. We'll be using this circuit for our next complete series of lectures. So a flyback converter is used in any power supply, any LED lighting power supply. It is filled up, the power supplies are filled with these converters. So the flyback converter consists of a transformer, which is L1, L2, which is primary and secondary, then a MOSFET, or you can think of it as a switch, ideal switch, and a diode and a capacitor, which is, I have modeled it as 1 millifarad, and an input source. This input source can be input mains 120 volts or 240, which you rectify it. I have taken 170, which is the rectified 120 volts AC. This is the peak value. I've modeled it as a voltage source, 170 volts. So when I turn on the switch, the current in this primary ramps up. When I turn off the switch, the diode conducts and the current ramps down. That's the basic operation of the flyback converter. So the current in the primary is the red waveform which ramps up, and when you turn off the primary side switch, the diode conducts and the current in the secondary ramps down. So this is how it looks like. This is a 100 kilohertz switching frequency from here all the way up to here. You would hear about flyback converters being operated in continuous conduction mode or a discontinuous conduction mode or a critical conduction mode. For the sake of the simplicity, we are operating the converter in critical conduction mode. Let's not get into continuous conduction mode or discontinuous conduction mode. All it means is, in a continuous conduction mode, the current would start from somewhere around, let's say, 2.5 amps, and it goes up like this and comes down. Whereas the secondary current, green current, would ramp up like this, and it would come down till 15 and go down completely. So that would be a continuous conduction mode. So whenever the current starts from 0, ramps up, comes down, that's a critical conduction mode. Something like this. Continuous mode, discontinuous mode, boundary mode, or critical conduction mode. Our circuit is operating in critical conduction mode, which is mostly all the power supplies, mostly the flyback will operate in. So the current ramps up, comes down, the current ramps down completely to 0. Whereas in continuous mode, it starts from a DC value and goes up, comes down. So our circuit is operating in critical conduction mode or boundary mode, and the primary switch is being operated at 100 kilohertz. So it's that fast, it's turning on and off, and we get the waveform that I was showing you. So this is a brief background. We will be modeling the transformer L1, L2 as primary and secondary, and we will take these waveforms, excite the transformer with that, and try to find the losses.